For decades, the possibility of extraterrestrial intelligence has captivated the minds of both scientists and dreamers alike. Though our telescopes have revealed billions of stars and planets, one fundamental question persists. Are we alone? In 2022, a potential clue emerged from an unexpected place, Kepler 438b, an exoplanet located roughly 470 light-years away. This world, only 1.5 times the size of Earth and residing in the habitable zone of its host star, immediately caught the attention of astrobiologists. It offered the tantalizing possibility that liquid water and perhaps life might exist on its surface. But what truly electrified the global scientific community was an unusual radio signal. Detected by China's massive FAST telescope, 500-meter aperture spherical telescope, the signal had an incredibly narrow frequency, about 1406.04 MHz, a range rarely produced by natural sources. This anomaly sparked a frenzy of speculation. Could this be a beacon from an alien civilization? China's Ministry of Science and Technology even publicly announced the discovery, claiming that their astronomers had found potential signs of extraterrestrial technology. Social media exploded. News outlets around the world picked up the story. The possibility that we had finally received a message from the stars gripped the public imagination. And then, suddenly, the story vanished. The report was mysteriously retracted without explanation. It was as if the event had never happened. This abrupt silence only fueled more speculation. Was the signal real? Had it been censored? Or was it simply a misunderstanding? Skeptics were quick to respond. Experts in SETI, Search for Extraterrestrial Intelligence, urged caution. Among them was Dr. Ware, a renowned SETI researcher at the University of California, who insisted the signal was likely a false positive, an artifact of radio interference from Earth. This is a recurring problem in the modern search for alien life. With countless electronic devices, satellites, and communication networks surrounding our planet, distinguishing genuine cosmic signals from human-made noise has become incredibly difficult. Even famous scientists have been fooled. In 1960, Dr. Frank Drake, creator of the iconic Drake equation, believed he had detected a signal from space, only to discover it came from a stray antenna on Earth. More recently, in 2019, a team observing Proxima Centauri, the nearest star system to ours, picked up a bizarre signal called BLC-1. It was long, steady, and unlike any other out of millions they scanned. But follow-up studies revealed the signal likely came from a malfunctioning device on Earth, possibly within just a few hundred miles of the observatory. There was even a case between 2011 and 2014 where a series of mysterious signals baffled scientists until they traced the source to a microwave oven being used during lunch breaks at the observatory. These stories remind us that the search for alien intelligence is not just a scientific pursuit. It's a puzzle laden with false leads and tantalizing dead ends. It's an effort that requires caution, rigor, and a healthy dose of skepticism. The modern search for extraterrestrial life hinges on our ability to detect signals, particularly radio transmissions, from distant worlds. But in the last few decades, one uncomfortable reality has emerged. Most unusual signals turn out to be false alarms. We've seen it happen repeatedly. Promising blips turn out to be microwave ovens. Curious frequencies, often local interference. As our planet becomes increasingly saturated with human-made signals from phones, satellites, and radio towers, it becomes harder and harder to pick out what might be genuine contact from the stars. The problem isn't just scientific, it's environmental. Earth's growing radio pollution is cluttering the silence of space, contaminating our instruments, and confusing our observations. It's like trying to hear a whisper in the middle of a crowded concert. This challenge has led some scientists to suggest a bold new approach: building a radio telescope on the far side of the moon. Shielded from Earth's electromagnetic noise by thousands of miles of rock, it could offer the clearest listening post in the solar system, a sanctuary of silence, perfect for scanning the stars. But even with better tools, we're still left with a haunting question. If intelligent life exists, why haven't we found it yet? This is the essence of the Fermi paradox, named after the physicist Enrico Fermi, who, during a casual lunch with colleagues, famously asked, "So, where is everybody?" It's a question that strikes at the heart of cosmic logic. With over 200 billion stars in our galaxy alone, and likely trillions of planets, many of them older than Earth, it seems statistically improbable that we are alone, and yet the silence remains. One explanation may lie in our limited search. We've only scanned a tiny fraction of stars, barely scratching the surface. In that sense, not hearing anything yet is unsurprising. Another possibility is that we're listening the wrong way. While we search for radio signals, an advanced civilization might use completely different methods: lasers, neutrinos, quantum entanglement, or even forms of communication we haven't discovered yet. History shows that our assumptions about cosmic communication can be naive. 200 years ago, scientists proposed building giant mirrors to reflect sunlight to Mars, or creating huge triangles of fire to prove Earth's intelligence. Today we chuckle at these ideas, but what if our current methods are just as primitive? It's also possible that alien civilizations don't want to be found, or worse, that intelligent life has a tendency to destroy itself before mastering interstellar contact, a grim but plausible scenario. Despite these sobering ideas, SETI researchers remain undeterred. They believe that with enough time, patience, and technological progress, the breakthrough will come, and it must come soon. Some scientists warn that the present moment is fleeting, a narrow window of opportunity between two eras. A past when our skies were clear but we lacked the tools to search, and a future where radio pollution may render the search impossible. In this delicate in-between, we search with urgency and with hope. The Fermi paradox poses a frustrating riddle. With billions of planets in our galaxy alone, why have we found no evidence of intelligent life? One answer may be simple: we're not looking in the right way. For most of the past century, our search for extraterrestrial intelligence, or SETI, has focused heavily on radio signals. The idea is that intelligent civilizations like ours might leak or transmit structured radio waves that we could intercept. But what if advanced civilizations have long since abandoned radio technology? What if they're using something beyond our comprehension? Signals encoded in neutrinos, gravitational waves, or forms of quantum entanglement that we can't yet decode. It's worth remembering that even in human history, our concepts of communication have evolved rapidly. In just over a century, we moved from Morse code to fiber optics and global satellite networks. So imagine what a civilization a million years ahead of us might use to communicate. Looking back, the earliest SETI ideas may seem almost laughable now. In the 1800s, scientists proposed lighting massive bonfires in geometrical patterns to signal life to Martians. Others considered building giant mirrors to flash sunlight across the void. There were even suggestions to carve massive triangles into the Sahara Desert to display our knowledge of the Pythagorean theorem. Today we shake our heads at those quaint ideas, but what if 200 years from now, people look back at our radio-based SETI efforts and say, how could they have been so blind? Some scientists argue we may be limited by our own biases. We expect other civilizations to behave like us, to use our technologies, think in familiar patterns, or even have the same curiosity to reach out. But what if they don't? What if they're listening, not speaking? Or what if they simply don't care to communicate? There's also the chilling possibility that technological civilizations don't last long, that self-destruction or natural disaster ends most of them before they can make contact. This would mean the universe may be teeming with life, but silent due to brief windows of visibility. Still, not all is lost. Advances in modern astronomy have allowed us to survey the sky with greater precision than ever before. With each new telescope, we peer deeper into the galactic dark, scanning millions of stars for the faintest hint of something artificial. Projects like Breakthrough Listen, backed by hundreds of millions of dollars, are using massive radio arrays and supercomputers to filter through petabytes of data, searching for anomalies. Others are using optical telescopes to search for ultra-fast laser pulses that could indicate alien technology. There's even the wild but increasingly discussed idea of building artificial intelligence to aid in the search, programs smart enough to identify unusual signals that human observers might miss entirely. SETI, at its core, is a lesson in humility. The cosmos is vast and old. We are young and small, but that very disparity should motivate us, not to despair, but to persist.
Our home planet, Earth, may feel immense in our daily lives, but from a cosmic perspective, it is nothing more than a dust mote suspended in a sunbeam. When we look upward at the stars, we're not just looking at light, we're witnessing time itself. Photons traveling for millions or even billions of years before finally reaching our eyes. These stars serve as ancient messengers, silently reminding us of the staggering scale of the universe. It's natural to ask, where does it all end? Does the universe have an edge, or does it go on forever? The late Stephen Hawking, along with other brilliant physicists, spent their lives contemplating these questions. In 1917, Albert Einstein himself proposed the idea of an expanding universe, an idea he initially doubted until evidence from astronomers like Hubble proved it true. The theory of general relativity shows that space itself is not static. It stretches, causing galaxies to drift further and further apart. Today, we estimate the universe to be 13.8 billion years old. That would suggest a maximum distance of 13.8 billion light-years. But that's just the age of the light, not the size of the universe itself. Because the universe has been expanding all this time, the most distant galaxies we've observed are actually about 46.5 billion light-years away in every direction. That means the observable universe is a sphere with a diameter of 93 billion light-years. And yet, that is only what we can see. To understand the full scale of the universe, we must first ask a deeper question. What shape is it? Space isn't necessarily flat. According to Einstein's theories, the universe could be positively curved, like a sphere, negatively curved, like a saddle, or flat, like an infinite plane. Each shape implies a very different destiny for the cosmos. If the universe is positively curved, like a 3D sphere, it might eventually loop back on itself. If it's flat, it could go on forever. And if it's negatively curved, it could expand endlessly, but with increasingly strange effects on geometry and gravity. To test these ideas, scientists used satellites like the Planck Observatory to measure tiny temperature fluctuations in the cosmic microwave background, the ancient light left over from the Big Bang. These fluctuations revealed clues about the geometry of space itself. The verdict? Within a 0.4% margin of error, the universe appears to be flat. But here's the twist. Just because something appears flat doesn't mean it is. After all, the Earth looks flat to us on the ground. Only when viewed from space do we see its curvature. The same could be true for the universe. Astronomers ran calculations based on the largest curvature still allowed by the data, and discovered that the entire universe could be at least 250 times larger than the observable part. That means a potential span of over 23 trillion light-years. To measure the true size of the universe, we have to define what we mean by the universe in the first place. What we can observe from Earth is limited by the speed of light and the age of the cosmos. Because light takes time to travel, the farther away we look, the further back in time we see. This defines the boundary of the observable universe, a sphere about 93 billion light-years across, centered around us. But this isn't a physical edge. There's no wall, no cliff, no end. It's simply the limit of what light has had time to reach us since the beginning of time, since the Big Bang. Think of it like standing in the middle of a dark forest with a flashlight. You can only see as far as your light reaches, but the forest continues beyond your sight. Similarly, the universe may go on infinitely, or it may wrap around itself. We just don't know. At the farthest reaches of what we can observe lies the cosmic microwave background, CMB, a faint glow of residual radiation from just 380,000 years after the Big Bang. This is the earliest light we can detect, and it forms a kind of horizon beyond which the universe is opaque to us. Even more fascinating, this early light carries clues to the universe's birth, to its geometry, expansion, and structure. And with powerful telescopes, we've captured snapshots of this ancient glow, effectively allowing us to look back in time nearly 14 billion years. But the question remains, what lies beyond the observable universe? There are a few possibilities. The universe is infinite. In this case, space goes on forever. Every direction we look would continue endlessly, with stars and galaxies beyond what we can see. The universe is finite but unbounded. Like the surface of a sphere, it loops back on itself. If you traveled far enough in one direction, you might eventually return to your starting point, though the scales involved are incomprehensibly large. There are multiple universes. Beyond our cosmic bubble could lie other universes entirely, with different laws of physics, what we call the multiverse. Each of these ideas challenges our understanding of existence, and yet all of them are consistent with current physics. One thing is certain, we will never be able to observe the entire universe, not even in theory. The fabric of space is expanding, and at such a rate that many galaxies are being pulled away from us faster than the speed of light, not because they're moving through space, but because space itself is stretching. That means there are parts of the universe we will never see. Not now, not ever, even if we had infinite time. But far from being depressing, this fact adds to the majesty and wonder of the cosmos. We are tiny participants in something so vast, so mysterious, that even our best efforts to measure it barely scratch the surface. Our story begins at home. Earth, a lush blue planet teeming with life, swirling clouds, deep oceans, and vast continents. It is the only known world where life exists and the cradle of human civilization. From space, the signs of humanity are still visible. Cities glowing like circuits, fields of agriculture etched across the land. But as we rise higher, those details fade. Countries vanish, continents blur. Eventually, even Earth itself becomes just a sphere of blue and white, orbiting an ordinary yellow star. That star, of course, is our sun. It powers our world, drives our climate, and fuels life through photosynthesis. But it is just one among hundreds of billions in our galaxy. As we ascend farther, the other planets of our solar system come into view. Mars, Jupiter, Saturn, their moons and rings gliding silently through the dark. The vast architecture of our solar neighborhood spreads before us. Yet the sun, once all-important, now looks small. Just another light amid the blackness. Beyond the orbit of Neptune lies interstellar space. Here, the gravitational pull of the sun grows weak, and cosmic particles from the galaxy take over. At this point, we are leaving the realm of everything human beings have ever touched or visited. Now we see our solar system in its entirety, a tiny bubble in an ocean of stars. Zooming out further, we arrive at our galactic home, the Milky Way. It stretches over 100,000 light-years, a sprawling spiral of dust, gas, and hundreds of billions of stars. From this distance, even the sun disappears from sight. Our solar system is no longer a speck. It is lost in the blur. And the Milky Way? It too is just one galaxy among trillions. All around it are other galaxies, some larger, some smaller, forming webs and clusters, bound by gravity, dancing through space. They stretch into the cosmic web, a vast filamentary structure of matter, with great voids between the luminous strands. From here, we see the universe as a glowing network, billions of galaxies, each with billions of stars, each with its own possible planetary systems. And Earth? Earth is nowhere to be found. This is the true scale of the cosmos. It humbles us. It challenges us. It reminds us how fragile and brief our lives really are. And yet, it is in this vast emptiness that we exist. Every thought we've had, every moment of love, war, discovery, and creativity, all of it took place on a small rock orbiting a small star in a small corner of one galaxy.
Our galaxy, the Milky Way, is but one of an estimated 2 trillion galaxies in the observable universe. Each one is a swirling collection of stars, gas, dust, and dark matter, bound together by gravity and spanning tens or even hundreds of thousands of light years. Seen from afar, galaxies resemble glowing pinwheels or shining clouds. Some are spirals like our own, others are elliptical or irregular. Each contains a history stretching back billions of years, filled with starbirths, supernovae, and planetary systems. But these galaxies are not stationary. They move, interact, and sometimes collide. Across the cosmos, galaxies are drawn toward each other in gravitational dances that can last billions of years. These galactic collisions don't usually result in stars smashing into one another because the spaces between stars are vast, but their effects are profound. The galaxies twist, stretch, and eventually merge, giving birth to new generations of stars. Massive clouds of gas are compressed, igniting stellar nurseries in a blaze of creation. Meanwhile, at the heart of nearly every large galaxy lies a supermassive black hole, millions or even billions of times more massive than our Sun. When galaxies collide, these central black holes may also spiral toward each other and eventually merge, releasing enormous gravitational waves, ripples in the very fabric of space-time. In the center of the Milky Way lies one such object, Sagittarius A, a supermassive black hole roughly 4 million times the mass of the Sun. Though invisible, its presence is undeniable, detected by the orbits of nearby stars and by the radio waves it emits. And yet, even the most massive galaxies are just pieces of a larger cosmic puzzle. Zoom out farther, and we find that galaxies are not randomly scattered. They form clusters, gravitationally bound groups of hundreds or thousands of galaxies. These clusters, in turn, are connected in vast filaments, creating what scientists call the cosmic web. This structure is the largest known in the universe. Picture a 3D network of glowing threads stretching across billions of light years, each strand made of galaxies, gas, and dark matter. Between these threads lie vast cosmic voids, regions nearly empty of matter. The cosmic web resembles the neural structure of a brain, hinting at an elegant organic order underlying the universe. It is a staggering realization. We are part of something so vast, so intricate, that its full shape may never be fully mapped. And yet, through telescopes and simulations, we are beginning to understand the patterns that shape everything, from the clustering of galaxies to the formation of stars, planets, and even life. This is not just beauty on a cosmic scale, it is order emerging from chaos, structure arising from randomness, and perhaps hidden within it lies the key to answering the deepest questions we have ever asked. As we zoom out beyond galaxies, clusters, and the cosmic web, Earth vanishes from view. The story of humanity, of everything we've ever known, becomes a footnote in a boundless cosmic drama. And yet, we are here. On a tiny blue planet, orbiting a humble star, a species has arisen that can question its origins, explore the cosmos, and seek meaning in the stars. That fact alone is remarkable. It's easy to fall into existential despair when we realize our smallness. Our planet is a grain of sand in a galactic beach, and our lives mere flickers in time. But perhaps, instead of feeling lost, we should feel honored to be part of something so immense. Consider this. Every atom in your body was forged in the heart of a dying star. Carbon, oxygen, calcium, iron, the very materials that make up our bones, blood, and brains were created in supernova explosions billions of years ago. We are not separate from the universe, we are made of it. The great astronomer Carl Sagan once said, "We are a way for the universe to know itself." And perhaps that's exactly what consciousness is. A phenomenon that arises when the cosmos becomes complex enough to reflect inward. We are the eyes and ears of the universe looking back across space and time, trying to understand its own story. But even now, our understanding is limited. We grasp only a sliver of what exists. Our minds, evolved for survival on Earth, struggle to comprehend concepts like infinity, curved space, and quantum uncertainty. We don't know why the universe exists. We don't know what lies beyond the observable horizon. We don't know if we're alone. But the beauty lies in not knowing, because that drives us to explore. Even in moments of hardship, there is comfort in perspective. The universe is vast, yes, but that vastness holds room for wonder, growth, and endless possibility. Our lives may be brief, but they are not meaningless. In fact, it may be our awareness of impermanence that gives life its urgency and beauty. We create art, seek knowledge, build civilizations, not despite our fragility, but because of it. And when we feel disconnected, we can remember that we are bound to the cosmos not just by physics, but by origin. You are not on Earth. You are Earth, and Earth is not just in the universe. It is the universe. Every sunrise, every breath, every heartbeat is a manifestation of cosmic processes unfolding on a human scale. In that light, we are not small, we are essential. Throughout this odyssey, we've marveled at the birth of stars, the scale of galaxies, the mystery of black holes, and the delicate dance of celestial bodies. We've explored theories about alien life, the nature of space-time, and the ultimate fate of the universe. And yet, for all we've uncovered, we are reminded of a humbling truth. We've only just begun. Our instruments grow sharper, our understanding deepens, but the cosmos still stretches beyond imagination, a tapestry so intricate that each discovery leads to new questions. What lies beyond the observable universe? Is there a multiverse? What caused the Big Bang? What happens after the last star dies? The pursuit of these answers is what makes us human. The universe isn't simply a place we live, it's a mystery we're meant to engage with piece by piece, generation after generation. And make no mistake, this story is still unfolding. The tools of tomorrow, AI-driven telescopes, gravitational wave observatories, interstellar probes, will open doors we've only dared to knock on. The scientists and explorers of the next century may well find proof of life elsewhere, map other galaxies in full detail, or even unlock the secrets of time itself. But the most powerful part of this story is that you are part of it. Each time you look at the night sky and wonder, each time you read, question, imagine, that's the universe within you, awakening. You are a witness to a grand cosmic evolution, a rare moment in time when life not only exists, but begins to understand itself. The stars above you are not just distant points of light. They are echoes of creation, calling us forward. So whether you are a scientist, a student, a dreamer, or simply someone captivated by the unknown, you are helping write this great story. With every question you ask, you turn the page. And maybe, someday, one of us will find the answer that changes everything.